X-Rite. And I'm very happy to introduce Ray Shadler, who's the Global OEM Manager, who will also be participating in this presentation. Ray, we welcome you to the webinar.
Hi, thanks, Jim. So
before we begin, let me just go over a couple of housekeeping things, and that will help our audience. We have a big audience today. If you'll notice that your phone is in mute. So if you have any questions throughout the presentation, just use the drop down and type in your questions, and at the end of the presentation, we will go over the questions in the Q&A session with Ray. So Ray, take it away.
Okay, so let's go on to slide 2. So we'll start off here. I think this is sort of an important piece where we generally think about printing and so forth as an objective, and the objective usually is for someone to communicate better, and often it's about selling a product. And one of the things we'll see in this piece here about market research, right, is that if we understand consumer behavior, we'll understand that they make decisions very quickly. And if we look at the big numbers on here, 60% there has an acceptance or rejection just based on color choices, and greater than 65% has an issue. They're making decisions based on color. So we can see that color becomes an important part. And as we move on to the next slide, we'll see some things that we're doing to try and address color specifically. And in this webinar, we'll talk about measurement standards and how we address some of the new challenges in color. So if we look at the ISO standards that we'll talk about today, we have ISO 13655, and we talk about this being a new standard, and yet it was redrafted last in 2009, but what it really says is standards take a while to be implemented, and so this is all about how we measure. And so this is really where we get the M factor in here. And so the M factor at this piece is what we'll talk about in the first half of this presentation. And then we have some things that line up against that as well. So the ISO 5 series, it has that very small number of 5 because it's one of the very first international standards ever drafted, the 5th one, obviously, was redrafted at the same time. And this is to bring the requirements for densitometry in line with the requirements for spectral measurement. And again, to make everything line up, we redrafted ISO 3664, which is all about how you view prints in the graphic arts. And so this piece then, all together, those three are all working together in concert when we're looking at print and when we're measuring print. And then we have the ISO 12647 series, probably the best known as 12647-2, which is offset, but there's a whole series for proofing and different printing processes that are also now either have just been reviewed and we have new versions out there, or final versions that are coming into play, which are also addressing some of these changes that happened in 13655 and ISO 5. So let's move on to the next slide.
Hey, Ray, before you go on, let me just launch a quick poll here.
Okay.
Because we're going to ask our attendees how familiar they were with this ISO. They were very familiar, they've heard about it, they've not heard about it. So if you have a chance, just go ahead and weigh in with your vote, and then we'll close this out in just a second. So, all right, Ray, we'll move on to the next slide.
No problem. So, yeah, Jim can't actually hit me on the shoulder since we're in 2 different places, so he has to yell at me. So what we have going here, though, is we've gone through a process of trying to make some things look better, and often when we change something in a process, problems emerge as well. So one of the things that has happened across the paper industry is the introduction of an increasing amount of optical brightening agents, or what we call OBAs. And then in some other products, we're seeing other kinds of fluorescent brightening agents or whitening agents that may be affecting our inks and our toners to give more pop in there. So the OBAs are there to try and get a brighter, whiter sheet, and then these other fluorescent agents are often used in inks and toners to get something that has a little more snap to it, if you will. And so if we move on to the next slide here, we'll get in a really quick picture here an idea of what goes on. So what happens when we go through this process is we see that different lighting is going to create different results, and this is all effect of this fact of having brighteners in there. So what we see is if we do the first bump here, we'll see some sheets of paper. It's a little hard to see on your screen perhaps, but there's 5 different, I think, sheets of paper there in the white sheets there, and they all look pretty much the same under tungsten lighting. And then we can also look at all of that crazy array of other materials in there and see under tungsten lighting one effect of how they look. If we then change the lighting and add in one additional lamp in here instead, so that we put in a traditional store lamp, we can see now that the overall colors of some of those objects in the back have changed, and in fact our papers have changed color a little bit, but they're still looking pretty similar to each other. So then the next step is if we go into daylight, now we're starting to see more changes. So obviously what we see when we go to daylight is everything has gotten bluer, and we're now starting to pick up, it's a little hard again on a webinar to see, but more differences in the paper stocks up front. And then to just sort of tell the story completely, if we go to the last image there and turn on just the UV lights, we can see one paper that is still white but blue, right? But that paper on the right is glowing bright, and then we have the paper on the far left, which is almost black. And that's really showing you the different amounts of brighteners that are in those different sheets. And so that's really the story here, is that when we change illumination, especially on these sheets that have a lot of brightener, that will have different effects. And we'll sort of walk through that process here. So on the next one, we'll really dive in here and talk about optical brightening agents. And like we said, they're put in there to solve a problem, but then they create some challenges as well, right? So they give that different looks. So as we remember that slide before, different amounts of optical brightening agents mean that if you have the ability to fluoresce them with your measuring instrument or your viewing condition, you will see different data and a different appearance. One of the things that is part of this story is that previous standards really didn't address OBAs, but they didn't address them because they weren't in use. So again, this is a question of addressing those things that as they come up. So the new standards are looking at this problem and giving you some new tools to address it. What was in the standard, which in theory would have addressed OBAs, was that the spectral measurement document, the 3665 document, recommended that you use D50. But that wasn't used because at the time it wasn't very practical for the instruments to be made that way, and it directly conflicted with ISO 5, the older standard, for density, and most people were using the same instrument measure both color and density. So as I said in the introduction then, all of these standards have been now revised so that they can both address the issue and be in harmony, so that you don't have a conflict between them. So if we look at the next slide here, we'll see that these M standards really break down into 4 different pieces, and we'll walk through each of these. But just as a highlight here, we have M0, and that's the historical choice. That means typically we're thinking that it's tungsten, but it has an undefined amount here, so that we'll walk through that piece there. And then we have M1, that daylight or D50, then M2, which is UV cut or UV excluded, and then M3, which is M2 plus polarization. So it has its own name, but it's really a combination of a polarization filter and a defined amount of UV cut. So what are we talking about here? We've spent lots of words here, but let's look at a picture here from the fact that how we actually go and would graph this from a spectral measurement. So if we look at the next slide here, we'll see that if we have materials with no optical brighteners there on the left, what we see is all of the spectral curves look pretty much the same. So we don't have to worry about it. And that's really something to remember. If you're using papers that have no optical brighteners, the fact that you're measuring with M1, M2, or M0, M1, or M2 really won't have any effect on the way your numbers are recorded. M3, because you're adding polarization, will change the numbers, but that's usually done when you have a specific need for that kind of cutting of that first surface reflection. So if we look on the right side, though, now we're looking at papers that have a lot of brighteners in there, and we can see that that curve, especially in the low end of the scale, down in that 420, 440 range, have very different curves. And this is really an effect then of both how many brighteners are there and the amount of excitation that happens from either your viewing condition or, in this case, your measuring condition. So we can see, as we might expect, UV cut has, no effect on the brightener. And then if we take what is sort of the de facto standard for use, which is that tungsten illumination, it gives us a pretty big curve and jumps above 100% there because it's absorbing down in the UV range and emitting up in the area we can see. And then if you take D50, it's that much more. So it's getting that much more of a bump. So if we then move on to the next one, we'll actually walk through each of these different M conditions. So we call M0 the default and the catch-all umbrella. So the idea here is, again, it's historical. This is where the majority of spectrophotometers and densitometers in the graphic arts have always had an incandescent lamp that was equal to or close to illuminant A. And so it is a catch-all because it has some wiggle room in its definition, specifically to cover historical instruments. But then on the other hand, if you have instrument manufacturers that have maintained that close consistency to illuminant A, like X-Rite and former Great Tech Macbeth did, then you have instruments that still produce a very consistent output when we're looking at papers as well. So, and the thing to remember also is that M0 is still the most commonly used illuminant in the graphic arts, and even though we don't have it, it isn't defined, the UV content isn't defined, we've had very successful interchange of data as long as we have instruments that have well-contained illuminant A. So that's one of the pieces. If we move on to the next slide here, we'll understand some best practices, right? So, part of it is this maintaining, making sure that you're using instruments that have maintained a tight control of illuminant A, and M0 then becomes a very practical workflow, which we've been using for years. It also then says, though, that from the ISO perspective, ISO says that if you are measuring something with OBAs or measuring fluorescent inks, M1 is preferred. But if M1 is not available, so you have a device that can't give you M1, then you want to make sure that you're using instruments that are of the same manufacturer and model when you're interchanging data, because you want to make sure that they have as close a modeling to each other of that fluorescent effect. So that brings us to M1. So M1 is really two parts. And each part is about reducing variation, and it also adds some additional pieces. So let's look at part one first. And that says that the light hitting the plane should match illuminant D50. So this is sort of that historical requirement, what was in 13655 before, but some advances in different types of illumination have and some color science pluses and so forth have given us the ability to build that into an instrument today. The important part to remember, though, is part one covers both papers, so the OBA content, and then colorants as well. So the part one is sort of the stiffer piece to meet, and it allows you to measure either brightened papers or, toners or inks that might fluoresce. So this is sort of the premier standard to hit. And if we look at part two is a little easier to hit because it's saying we're really only worried about the effect of OBAs. And so this allows us to do some modeling that goes on there and compensate for the amount of UV component in the illumination sample. So we can do some pieces in there that allow us to model the effect of OBAs. And so this really says if we have an M1 instrument that meets part two, you wouldn't want to use this to look at fluorescent inks, but it's the great tool then to deal with this OBA problem. And as noted here in the call out, the other piece here is that these M1 condition is really tied to that viewing standard as well. So in 2009, the amount of UV required in the viewing standard was tightened up. So it made the requirement for the amount of UV a little bit tighter. And so you want to make sure that if you're measuring an M1, that you've got a viewing booth that meets that current standard, or conversely, if you have a viewing booth that meets the current standard, it might be a time to look and see how M1 may increase the agreement between your measuring and your viewing. So this is where we start walking down that path of figuring out what is the best workflow for you. So then if we move on to M2, M2 defines UV cut. And so if you had been a M2 user before, you might be like that person in the screen there, because what had happened was M2 had never been specified. So UV cut was different from manufacturer to manufacturer, depending on how the curve of their filter or their light source or whatever they used to create that measurement. So that we actually had a bigger disagreement in M2 measurement in the past than we did on M0 devices. So this is the other plus here is that it gives us a very easy way to talk about this UV exclusion, because people talk about it as UV cut or no UV or UV no or UV filtered, and so it became confusing when exchanging data often about whether that meant that the UV filter was cut or the UV light was cut and so forth. So if we all move to the description of M2, meaning that there's no UV in the light source, that'll aid some confusion in exchanging data. So the other part that's really nice here is that many old instruments, so ones that were built before this standard was ratified, may actually meet the current M2 condition. So there's a nice test inside of 13655 that a manufacturer can use, but it's also something that a user could use to test if their M2 device is compliant. So then let's move on to the next slide and talk about the last of the M's, and this is M3. So the M3 measurement standard is really a specialized use case in spectrophotometry. We tend to use M3 more often in densitometry, polarization when we're measuring density, but in spectral it tends to be much more of a limited use case. But this at least then defines for both conditions, both ISO 5 and in 13655, how polarization should work. So this defines the polarization filter, and since all polarizers cut UV to some extent, make sure that they now meet the same requirement that was in M2, so that all polarization measurements then are both UV cut and have a defined effect of how that polarization works. So this is, again, a big plus. It means that as we exchange data between different instruments that are polarized, if we know they meet the current specification, that we'll get better agreement from instrument to instrument. So now let's look at where ISO currently recommends that these different M conditions be used. So on this next slide here, we'll see the M standards across the top, and we'll say, okay, so the ISO says the best way to measure the effect of OVAs is to use an M1 instrument, either part 1 or part 2. And then the next, if we need to measure ink fluorescence, the best option is an M1 part 1 device. And then we might have a sub-bullet there that if you have an M0 device and you're exchanging data, you just want to make sure that you're exchanging it with someone who has a similar device. And then if we need to measure stocks that don't have OVAs, really everything's wide open other than M3, because as we saw before, when we measured a brightened stock with any of the illuminants, we got the same result. And then if we need to cut the effective OBAs, so we know they're in the paper, but we want to cut them out because we may be doing a process control where we don't want to see that, or we've got a color management process that works better that way, then we would go to M2 or M3. And then, of course, the only way to really cut those first surface reflections is to use polarization, which is that M3. But the bottom part is probably the most important of anything, which is really to agree on what M standard you're using if you have to exchange data. So you have a workflow question about what M standard you may want to use to make your whole workflow work as cleanly as possible. But the next piece is if you need to exchange data or meet data standards, then you need to agree and check that M standard before you start doing that process. So that's what we'll see as we move to this next slide. We see that while the current standards, the ones that are currently published today, are primarily established around M0 instrumentation, or no standard in the sense that they're not considering any brightness level at all, that there are no OBAs in the paper that they're looking at. M0 is really the de facto standard because that's what they were actually measured with for M0 devices. But what we're seeing, of course, now is a lot more of OBA brightened substrates, and some additional fluorescent colorants. And so that really drives attention to the problem. And we're seeing now in the emerging standards ways to measure in M0 or M1, with M1 often being the preferred option if you have a workflow that can incorporate all those pieces. So what we're going to see as we emerge in just the next year, more and more standards that are going to be pushing the idea of measuring OBA papers with an M1 device. So I think at that point, I turn it over to Jim.
Okay, Ray, that's a fantastic overview. Thank you very much for helping us to understand the context and the current situation. And we'd just like to add to Ray's message that, so in order to address this need, we have some tools to help, as you would expect from X-Rite. And so the first tool is the i1 Pro 2. Now, this is a device that is kind of the de facto standard for creating profiles in the industry. And when we released the new i1 Pro 2 about 9 months ago, this was the first device that could actually do the M1 measurements. So as you can see in this slide, this has the advantage of being able to create the profiles and being able to see that and measure into the different M standards. And so the i1 Pro 2 has this ability. Also, too, you'll notice that it has new features. It's a complete redesign. You'll find that the ability to scan, there's some, as it says down the lower left, through the LED indicators. It's kind of a scan, error-proof scanning, because as you go along, because of the new technology involved, and you can kind of see it mentioned over in the lower right with those bars, there's actually a sensor on the bottom of that, so it always knows where it is as it's measuring the patches. So for your pre-press, to have the ability to have a spectrophotometer in the pre-press that can measure M1 is important, and so we have the i1 Pro 2 available for that. The other bit of exciting news, and this is a new release for us, it's a complete new product that was released at the end of November, is the X-Rite Exact. I'm sure many of you have heard of this. This is a new press room handheld spectrophotometer, and it's really a complete redesign. As you know, X-Rite and combining the legacy Graytag and Macbeth technologies, we decided to have a ground-up redesign based on the latest technology and optics, the new chassis, the electronics, the onboard storage. All of these things have been put and designed into the new Exact. It supports the latest industry standards. We'll talk about that a little bit later. And the underpinning of all of this is that it's XRGA compliant. So when Ray was talking before about having the ability for devices to measure the same way and having a tight correspondence between the devices, XRGA is an effort to create that standard so that you have an agreement from model to model. So if you have a multiple site or multiple locations in your operation, the ability for your devices to measure the same way, if they are XRGA compliant, then you'll find that to be the case. For our customers' use, there's big value for you. As we mentioned before, the ability to do all of the measurement standards for M1 in both Part 1 or Part 2. M1 Part 1 obviously will allow you to measure both the fluorescence in the paper, the OBAs in the paper, and the fluorescence in the inks, but also M0, M2, and M3. If I go back to a step, for some of you who are interested in the i1 Pro and the pre-press, you might have remembered that when you ordered the i1 Pro before, you had to order either a UV cut or a UV device. All of that is now eliminated, so the same device will be able to measure, and that's kind of what shows here by the M0, M2, and M3. The device can either have the UV or cut the UV. Now for your press room, you'll find that the ease of use is great. It's kind of designed with the idea of the iPhone. So it's kind of a touch and swipe technology that you'll find in the window. So it will provide ease of use in the press room. Another thing that is to create efficiencies in the press room is many of you have been using them, have tried to, sometimes have lost the calibration tile. But if you notice in that illustration, underneath where the reading, where the eye would be, you notice there's like a little plaque. And so it's kind of it has a built-in auto calibration feature in the Exact. And so that will be something that if it's sitting in the cradle, it can do an auto calibration. So that important step is always taken, and you won't ever lose the calibration because it's, the white tile is actually built into the device. Something also very important is that as it supports all of the ISO standards and the measurement conditions, we're going to find that it's compliant with different G7 and so forth. And so before we get into that slide, you'll be able to use the Exact to measure to those standards. You'll be able to create templates and then measure and then measure against the G7 standard, and then enter have the ability to have that information and that data entered into kind of adjacent software. So there's great value for the customer in using this new technology. And again, we want to stress that the Exact is the only device that can support both the M1 Part 1 and the M1 Part 2. Now, many of you have instruments from X-Rite or other devices, and we want to let you know that there's a customer loyalty program where your current densitometer or spectrophotometer is worth up to $1,000. So if you were to purchase an Exact, there's 3 different models that you could purchase. If you have a device in your operations right now, you can, I'm going to send out right now to all of you, so you can look in your window. I've sent a link to you, so you can link, and you can actually click over and link to it. There's the bottom link allows you to go to the page that has all the questions and answers about how to actually submit a claim in this customer loyalty trade-in program. But also we have a promotion right now. Some of you actually were writing questions about getting a live demo of the device. And so if you click on that link, the bit.ly link, the first one, where it says, here's the link to enter the Double Down promotion in the note that I sent out in the chat, you'll be able to actually just sign up. You would actually register to win. We're going to have a drawing at the end of the promotion where we're going to give away an Exact Advanced, an i1 Publish Pro, and i1 Display Pros. But actually the real value is you'd be able to have a hands-on, an X-Rite representative would be able to visit you and actually give you a demonstration of the i1 Pro 2 or the Exact. So we want you to be aware of that. So go ahead and click on those links and you'll be able to find that information. So again, you can kind of see in that picture, there's the touch and swipe technology. It's really user-friendly, and on a lot of your operations where you have turnover in your production, the ability to make that process simple is very, very important. In fact, your press room operators can log in under their own name, and there'll be certain profiles that will be established so that the tasks that they need to do, let's say, for example, they only want to do densitometry and get those kinds of readings, they can just have access to that. So it's the device is flexible and easy to use. The best match feature is also something that's very valuable to allow your pressman to understand right away whether this spot color will be able to be hit and what you would need to do in order to match that color. And that's also, as it feeds into the value of this device into your productivity, because at the end of the day, you need to be able to take paper and product that comes off the back of your press and understand, does this pass or fail? And so based on the different standards that you may be using, the device can be set up and very quickly understand if you've actually met those specs or not. One of the things that's great about the Exact, and it's a real great differentiator, is it's really part of a greater ecosystem of software. So in addition to the Exact, you can use it with Net Profiler. Net Profiler is a software that will allow you to ensure that if you have multiple site, let's say locations, that all of the devices that you're using in your network are actually calibrated to the manufacturer's spec. So, and that's done through the net, or the internet. So it's an ability for you to use the software and make sure that your devices are in line and be able to have the reporting on that as well. Color IQC Print is another great software product that's used in conjunction with the Exact that will allow you to create reports and understand exactly what's happening with jobs. So this is a reporting software that, again, used in compliance with the different industry standards, will allow you to instantly see and track what's happening with your production. So as we mentioned here, there's great value in the Exact for you. One of the things that you can be able to do, as it mentioned at the top, is protecting the investment that you would make in the Exact. We have technical support and services where extended warranties will allow you to make sure that your device is always going to be operating in the optimal condition. As we talk about the second green bar, we have training that's available. So we have opportunities to train your operators, extend their product knowledge, and also have G7 certification. That's also a service that we would be able to offer. But it talks about your ability to optimize and improve your quality control. We also, our experts can come in and assist you with that if that's something that you would need. As you would expect from the color experts, that's a service that we would provide. And all of this is going to maximize your productivity. And by being more productive, as we see all of the printing industry is being pressed to become more productive, we feel that this is going to give you faster responses and lower your waste and thus maximize your profitability. So we thank you for your attention to that. Before we go into our Q&A session, I'd like to launch another poll here for you. Maybe you can give us your feedback on another question. And as I'm queuing up this poll, if you could then, let's see here. For some reason, the second poll is not going to show up. So we will move right into our Q&A session. So Ray, you're still with me?
I'm here.
All right, very good. So the first question that we have for you is, do the Graytag Spectralino instruments with a UV cut filter satisfy the M2 spec?
And the short answer is I'm not sure. I believe they do, but you know, that instrument was discontinued long before that spec actually got written. So I don't know that we've actually done an official test against that, but that shaping is very close. The current shaping is very close to the traditional UV cut filter used in Graytag Macbeth instruments. So I suspect it's probably, if not an exact match, it's pretty close. I think the concern might be is that those instruments are no longer certified, so that might be more of an issue. Okay, very good. The second question has to do with the upgrade path from i1 Pro to i1 Pro 2. I can handle that question. We are in the process of finalizing a program that will be released in 2 weeks with regard to the upgrade path. A number of customers have asked, well, how can I take my existing i1 Pro device and I just want to swap it out and get the new i1 Pro 2 device? That will be unveiled in 2 weeks, so stay tuned for that. What you'll find is that there'll be an upgrade path from device to device, and then there's also an upgrade path that includes the i1 Profiler software. So if you're looking at our product line, you'll notice that the hardware and the software is bundled together in what's called i1 Publish Pro 2. And then if you want just the i1 Pro 2 device,
That's called I1 Basic Pro 2. So information about the upgrade will be available within 2 weeks, so stay tuned for that. Next question. If we're using the X-Rite Exact with M1 standards, but our vendors use an older spectrophotometer using M0 standards, will our readings be different?
Can you say that one more time?
So if we're using the X-Rite Exact with M1 standards, but our vendors are using an older spectrophotometer using M0, will our readings be different?
So the answer will depend on whether the material you're reading has optical brighteners or not. If you remember the two graphs that were early on in the presentation, one of them showed measuring with M0, M1, and M2, and all of the curves neatly lined up with each other. And then on the other, the curves diverged in that 400 to 440 range. And that was really an effect of how much optical brightener was in the material. So if you're measuring something with a lot of optical brightener, then yes. But then in that case, if you were trying to match your vendor, the nice thing about the Exact is you can switch directly over to M0. And so if you're both measuring M0, you should get good alignment.
Okay. Does the Exact display Pantone libraries and read delta E differences?
Absolutely.
Yeah. Yeah, that was one of the key differentiators, and I don't think one of our slides mentioned it, but absolutely, that's the other big thing, that the Exact comes loaded with all of the Pantone libraries. Can Exact export data to Excel?
It actually comes with a utility to do exactly that. So out of the box, it has a really nicely configured tool to be able to export to to Excel, and you can choose whether you put label identifiers on there or take them out, or how the data gets formatted. It's pretty flexible.
Okay. There's a question here, Ray, about opacity. It says, I'm in the flexo industry where we print on white opaque polyethylene or clear with white or an ink base. Our current X-Rite is the 939, can measure opacity, which is very important to us. Can the Exact spectrum measure opacity?
The same way that the 939 does, yes.
Okay, all right, very good. What is the benefit of going with the Exact as opposed to keeping the 530 model with the color manager software?
Well, I mean, I think the Exact is just that next jump. It reads faster. It has more availability of information on the screen. It has all the different illuminants. It's got, I mean, it's just the next generation. It's 10 years of advances in science and design all wrapped into one package. So it's a big jump over the 530.
Okay. Can QA master information be imported into the IQC print software with the Exact?
There is a way to move databases, but that's an area that I am not familiar with, so that's one I probably will have to pass on. And we'd have to call our support folks to know the exact path to go do that.
Okay. Can the Exact be used to measure textiles like an SP62?
So that's a yes and no question all in once. It is a 045 instrument. It does have the ability you can buy one with a large aperture, which may be exactly what you want for some fine-grained textures. But certainly the sphere-based instruments have a totally different geometry, and if that's the geometry that you need, you've got coarser grain, or you're trying to get both a measurement of both color and appearance, then a sphere is the right tool for the job. And we make different tools to solve different problems. So the Exact is good for certain cases where 045 is appropriate in the textile world, but when you need a sphere, there's nothing that'll beat a sphere.
Okay, very good. Can the Exact connect to the computer via Wi-Fi or Bluetooth?
It connects either via USB or Bluetooth.
Yeah, so it does connect to Bluetooth. And can we plug in the Exact to our existing software, which is QA Master Formulation Master 8.0.4?
Version number I'm not sure of. There is the ability to connect an Exact into X-Rite Color Master, though.
Okay, very good. What's the difference between Exact Standard and Advanced?
it's probably better to see that graphically in the charts. So essentially, I mean, we build features depending on the level of instrument that you get. So I don't have a chart in front of me, so I don't want to misconvey what that information is. I think Jim sent out a chart actually or a link to a chart that gives you exactly what the breakdown is between the 3 instruments.
Yeah, that's right. Well, we have come to the end of our time allotment for this. We appreciate your attention. I apologize, there's many other questions, but we've come to the end of our time session. We appreciate your kind attention throughout this webinar. Thank you, Ray, for your time today. And if there's, you'll be getting a link. Some of you have asked about the ability to download a copy. You'll be getting a link where you'll be able to see the webinar again. So, and a note from me later on. So, if you have any questions, just feel free to respond to that email that you'll be getting later on. So, at this point, we conclude our webinar, and thank you very much for your attendance.